All right. Hi, everyone. I want to just start by apologizing a little bit. I was planning on having a lot of time for preparing, and then reality came and kind of put a stopper for that. So if this talk is not very long, if people have questions in the end, that's fine. And if people want to know some more afterwards, just come to me, and I'm happy to talk more about this. So yeah, I will be talking a little bit about a project I've been working on at Collabora called Zink. It's an OpenGL implementation on top of Vulkan as part of Mesa. Yeah, so I'm gonna first go through a little bit of the kind of obligatory stuff. Why do we want to do OpenGL on top of Vulkan rather than normal OpenGL drivers? One of the reasons is that OpenGL is becoming more and more obvious that it's kind of heading towards obsoleteness at some point. And Vulkan has taken over kind of as the cross-platform API that has a bright and shining future. But there's still a lot of old applications out there that needs to keep working, and some of these will probably never be ported over for various reasons. Some of them just don't get any benefit from the rather complex rewrite, and some of them may not. The source might not exist any longer, or the vendor might be out of business, or a gazillion other kind of weird little reasons. It's also better for the community to focus on one API going forward. There's fewer GPU drivers to maintain, and maintaining a Vulkan driver is significantly easier than maintaining an OpenGL driver. Yeah, so there's also simplifies the parts that needs to kind of fit together in the software stack. There's fewer points to integrate. We can also support OpenGL on platforms where it's hasn't yet been possible. And we don't even need the platform provider's support directly for this. We can ship OpenGL as a part of dependencies for our application instead. So yeah, Zink is a solution for this. It's a Gallium driver that translates Gallium API calls into Vulkan calls. It basically looks very similar to a normal GPU driver, but instead of having mapping up memory and stuff like that using kernel calls, it uses Vulkan calls. When you pair that together with Gallium's OpenGL state tracker, you get a full OpenGL implementation. We're currently supporting OpenGL 2.1. As well as OpenGL ES 2.0. There's a few pitfalls. I will go through those a bit later, or some of those at least. So yeah, first I want to show a little bit of how well it works. So this terminal is very small now after. One of my favorite things to run and stuff like this is Quake. I love Quake. And you can see here that it's, oops, this is hard to control while holding the mic. I'm going to do this. So, it runs, I would say, decently over 60 FPS much of the time on top of a Intel GPU that, it's no more than half the performance currently, and this is without very extensive performance work. We can also run, for instance, Blender to just show that some bigger, kind of more complicated software also works. I don't really know how to use Blender, so all I can do is really zoom in and out and move things here, but so yeah, anyway. It's not, I guess, super exciting, but it's something. And then I'm going to show the benchmark. the forever benchmark indeed. And here, some of you might notice that there's something weird going on here, and that's because of flat shading, provoking vertex incompatibility, which is one of the kind of tricky things that I haven't fixed yet. So yeah, back to the talk. So this is a very kind of simplistic view of how Zink fits into Mesa and the stack. And here's a little bit of an outdated but somewhat accurate kind of inner description. It's yeah, it takes different parts from Gallium and kind of stitches them together into some caches and things like that. So the more important things there are, I think, the pipeline cache and the program cache that will yeah, be used for somewhat efficient state yeah, state execution. So one thing that's not in that drawing, because that drawing is a bit old, is that we've added, since last time I presented about this, or presented about it in detail, we added some batching, and it's not extremely sophisticated. We just have like some Zink batch objects that has a bunch of resources on them, and are used in a round-robin fashion and flushed and stalled for whenever we're out of batches. Each of them contain a command buffer and a descriptor pool of fixed sizes, and they keep VK sampler objects alive until they're done. Well, until they're reused, because if you delete the sampler while it's still referenced, Vulkan doesn't like that. Yeah, and it will flush. Will flush to use a different Zink batch object whenever a frame buffer is switched. This is just to kind of reduce some tracking complexity. Whenever there's an actual kind of flush from the API, or whenever the descriptor pool runs out of descriptors. Yeah, so some of the pitfalls here, and I'm just going to go through a few of them because it's to kind of illustrate the problems here. So yeah, two-sided polygon mode is difficult to do in Vulkan. I'm leaning towards saying it's impossible. I have no good idea of how to implement that without going completely haywire. Yeah, line rasterization rules. We have a new extension, but for platforms that don't have that, we're going to be out of spec. So we could implement the diamond exit rule in the fragment shaders. I'm not super tempted on that, but Angle has an implementation of that, and it's not too bad performance-wise, but yeah. Yeah, and there's many more. I've had this talk several times before, or variations of it, and I've listed different kind of issues in some of them. Yeah, so there's some other there if you're interested, and there's also on the issue tracker here on GitLab, freedesktop.org under my user. Yeah, so the next thing, which for the next, like right now, I'm not really focused on adding any more features right now. I want to upstream in Mesa. So I've sent the first preparatory merge requests this morning. And I'm hoping to rebase the rest of the stuff and get it in a proper reviewable merge request within the next few weeks. And yeah, the problem is that we're several companies working on Zink right now, and everything having to go through me is painful. For instance, whenever I'm on vacation, like no one gets to synchronize. Yeah, and it's painful to have to rebase on top of Mesa Master all of the time. And yeah, we will also get better scrutiny, I hope. We have some changes to the Gallium state tracker. I will go through those in the next slide, I think, or some of them at least. Yeah, you can build as part of the distro also for if someone is crazy enough to try using this in production. Yeah, so the changes to Gallium. Some of the most significant ones are that I've there's some features that I see re-implemented in several drivers over and over again, and I've kind of tried to write generic state tracker lowering of this stuff instead of doing it again and again. My reasoning for that is that if it's not supported in Vulkan, there's a good chance that it's not going to be supported in some future hardware, and maybe some mobile hardware isn't going to support it already. So it's probably other hardware driver is going to have this problem to some degree. So one of them is flat shading. We lower that into just flat specifiers on the shaders. Alpha testing, we're lowering into conditional discard. Point size forwarding, which is when you use points without any size written from the vertex shader. Yeah, two-sided lighting and user-defined clip lanes. So we're trying to do this in the state tracker and part of the shader keys in there. So it happens, and this is all by caps from the driver. Yeah, and the user-defined clip lanes, which I've seen in many of the different drivers that implement this themselves, is that they have to keep some extra shadow state that they need to kind of glue into their uniform blocks in the end, and yeah, from manual inspection, it looked like a few of them had forgotten some invalidation flags and things like that. So hopefully we can fix things like that once. Yeah, and then there's also some patches to prefer using R8 textures in a few cases where we weren't. I think this is specifically for GL bitmap usage. Yeah, and yeah, we'll probably send these things, the Gallium changes, first as a series without adding the rest of Zink. So it's probably a bit easier to review, I'm hoping. Yeah, and then once that is done, I wanna add continuous integration into the mix. And since Swift Shader has implemented a Vulkan software renderer, we can use that so we don't have to depend on specific hardware anywhere in the GitLab CI builders. It's completely untested, but you know, if someone wants to have a look at this, that would be great. Yeah, that's it. Any questions?
Thanks for the presentation. Do you think it's possible that just like for the XVK, Kronos is gonna work on creating new interfaces in order to well, allow drivers to expose what is needed for Zink?
Well, I think there's a fair chance of that. I think this is, we probably need to kind of spearhead that, I think. Probably since we have a couple of open source Vulkan drivers in Mesa, we can start the work there and make EXT extensions and propose them to Kronos. So, and I think that's a good way forward, at least for getting features that are particularly hard to implement. Although I have some pause in relying on too much on that, because some of these things weren't added to Vulkan for a reason. And yeah, so if it's like particularly crafty, not very useful things, maybe we can get away with ignoring it or, you know, doing some stuff that's, yeah, not great. Like what? Right. I think different companies have different policies on that, but yeah.
Have you taken any look at running this over the molten VK, the Vulkan portability layer, and see how much would that affect Zink?
Right. So I personally haven't done that, but there is an interesting company that does exactly this. They're also not an insignificant one. They are the foundry who makes Nuke and some other Hollywood production tools. They are, because their problem is that Apple has deprecated OpenGL, and they're currently running like a chicken game, who will pull the trigger first situation. So they are afraid that Apple will cut OpenGL entirely, and they need to have a backup plan. So they are contributing to Zink. There's Duncan from the Foundry has sent a bunch of patches recently, fixing some pretty obvious mistakes. So that's great stuff. Yeah. So in all, it seems to work, and it seems the performance is not too bad. Yeah.
Not really a question, but just a statement about the fixed function lowering. Given the number of drivers we have for glass hardware these days, maybe it's time to revisit moving some of that to the Mesa State Tracker instead of duplicating it in a bunch of different driver backends.
Yeah, that's exactly kind of my thought here. Like, it seems to me some of these things have a little bit of a strange position in there, where they're like a mixture of fixed function and programmable pipeline state in the same interface. So I agree. There's maybe some of these won't be optional down the line. For instance, we'll have to see. I mean, if some driver benefits greatly from it, I think there's no harm. But yeah.
First, thanks for the great talk and the great work. Zink is a really cool project. I wanted to know if you think that the performance of Zink is eventually going to be competitive with the performance of other Gallium drivers.
I'm not going to make any bold claims here, because that sounds like I could easily step on someone's toes. But I'm surprised with how little performance effort I've had to done so far to get somewhat competitive performance. So I wouldn't be too surprised, but I'm not, like, I haven't really gone too far down the performance line yet to say anything concrete. I don't think there's any obvious bottlenecks. I think all of that stuff would be things that comes, like, there's a little bit more overhead in maintaining the pipeline objects and things like that. But I'm guessing similar, like, from what I can tell, most drivers has something similar, so it's probably not going to be too bad. But the key, the hash map key for the pipeline object is pretty big. So comparisons that there probably are going to need some work on kind of invalidating which bits needs to be updated when, things like that.
Just to all the way over here, to kind of half add to that, what we've seen with DXVK trying to do D3D10 and 11 translation to Vulkan, which is basically the same problem, they're very similar APIs, is that the performance is actually really pretty good. There's even cases where DXVK beats the native D3D11 drivers running on the native platform. So like the performance can be gotten. The biggest issue is, like he said, the pipeline caching. That's like the one problem we haven't gotten solved in DXVK yet, is just that there's a lot more hitching, because you can't, like with Vulkan, you can't even really guess what, like all the OpenGL drivers, the moment you create a shader, they try and guess what the non-orthogonal state is going to be and pre-compile and do all sorts of tricks to try and avoid stuff. And a translation layer just does not have the tools to do those tricks now. So
I also want to point out that last time I did any performance, like look at currently where the shoe is pressing, it actually ends up almost all of the time going in the Vulkan driver, because I'm invalid or like uploading way too much state and stuff way too often. So, you know, pretty easy things I think to fix, but yeah.
As far as you asked the question about, somebody talked about adding Vulkan extensions for things, and with my kind of half Kronos, half Intel hat on. We're always happy to do that sort of thing if there's a genuine need for it. If you're asking for us to add two-sided fill modes to the API without an actual client that needs them, then we're going to be a little bit grumpy about it. But if there's an actual need for something, we've done it before. We did transform feedback because we needed it for Streamout and DXVK. We've done a few other extensions for various things that are needed, and we're happy to do that. So yeah, this is a really cool project, and I'm very happy to support it and see it going forward.
Thank you. All right, that looks like that's it. Well, thank you everyone for your time.